I'll just introduce myself. My name's Andrew Lawrence. I'm Associate Director here at the Florey. I'm also Head of the Division of Behavioural Neuroscience. My research interest is addiction, in particular relapse. I hope some of you have picked up something from that slide, which is done deliberately. And the reason it's done deliberately is because, and this is a lot of things that a lot of people don't consider, is that long-term substance use actually causes significant cognitive decline. Okay, I know how to spell. I also have spell check, so it's the kind of thing that you can't. It's very hard to make spelling errors like that deliberately these days. But I did it just for a reason, just to demonstrate the point that it's an often under-considered aspect of substance abuse, particularly long-term heavy drug and alcohol use, is dramatic cognitive decline, and it can also precipitate the onset of dementias. But we won't really talk about that too much today. So, how many people smoke in the audience? How many people used to smoke, stopped smoking, started smoking, stopped smoking, started smoking? It's addiction in a nutshell. Everybody, you know, when you say the word addiction, people think heroin addicts. But that's the minority of people. You know, 97% of all drug-related deaths are due to alcohol and tobacco. So alcohol and tobacco are drugs. The only difference is they're legal drugs, and heroin and cocaine are illegal drugs. But your brain doesn't know the law, okay? And so but if you think about it, what's happening with a smoker, and people think, oh, you know, bad luck, you know, you tried to quit, and then you started again. And then you stopped again, and then you started again. And that is addiction. It's a chronic relapsing disorder. And that's what people are doing when they're smoking. It's just they're chronically relapsing to something that's legal. So people don't stigmatise smokers. So someone who starts smoking again, oh, that's okay. But someone who stopped using heroin and starts using it, oh, they're a bum. But it's the same. There's no difference. Philosophically, there's no difference. And as you can see here, smoking is the single largest preventable cause of death in the world. And about 12.5% of deaths every day are a result of substance abuse. 12.5% of all deaths around the world every day are caused by substance abuse. And in the state of Victoria, it's a statistic I've been given by the director of Turning Point, which is the single largest drug and alcohol treatment centre in the country. The leading cause of death in males in Victoria under 50 years of age is alcohol. The leading cause of death in males under 50 in Victoria. So, sobering thought. Anyhow, what I would try and convince you all is that it's not some kind of moral weakness, it's not some kind of personal flaw that the person has. They've got a brain disorder, okay? Here you see an image of a healthy brain. This is just metabolic activity in a human brain, and here you can see in a cocaine addict's brain. It's dysfunctional, okay? Some people might argue that that's not a disease. I would argue that it is a disease, it's a disorder. No one would argue that this heart is a diseased heart compared to a healthy heart. So what's the difference? Healthy brain, diseased brain. Healthy heart, diseased heart. It's a disease, okay? It's a disorder of the brain. It's been around a long time. Here's a quote. There's a few quotes throughout this talk. The mouth of a perfectly contented man is filled with beer, okay? Now, some of you might say, okay, whiskey or wine or whatever, but anyhow, it's not a recent quote. It's 5,000 years old, okay? And this was in the ancient Egyptians. And here's a picture of the ancient Egyptians. You can see down here the servants bringing in the food, bringing in the wine, consuming the wine, and then the consequences of overindulging, bringing the wine back up again. So you see, they knew this 4,500 years ago. We haven't learnt a lot in 4,500 years, have we? But the point is, it's not a disease of modern society. It's something that's been around pretty much ever since humans realised that they could do things to alter the state of mind. And then we go to present day, and we have now You know, the Simpsons tell us that it's the cause and solution to all of life's problems. But you know, later on they realise that it's just a temporary solution. But the serious point is that it gets into our society and it becomes amusing, and it becomes accepted, and it becomes something that is an expected thing to do as well. But if we look at some statistics, this is from the Daily Telegraph in the UK, 2006, almost 10 years ago. 23 people a day in the UK are dying as a result of the consequences of binge drinking. And that's 10 years ago. 23 people a day in one country. Okay, now I'm going to show you a clip off YouTube. It worked when I was testing it. And this is the glorification of consuming large amounts of alcohol. This guy drinks 6 beers in 10 seconds, and it's on YouTube. You can look at, here you go. So you see, not only did he do it, and did he get himself, it's like Jake Carlisle with cocaine yesterday, isn't it? Anyone that follows AFL. But he was seen as to be a bit of a hero by all of his mates by being able to do that, you see. So, what is this kind of behaviour, and how does our behaviour impact our survival, and how does this relate to, you can see I can spell addiction now, you see. Well, the bottom line is that acts that are necessary to prevent extinction, and the two most obvious are eating and procreating, because if you don't eat, you'll die, and if you don't reproduce, your species will become extinct. They are positively reinforcing, and therefore they're behaviours that are repeated, okay? But there's a catch, because dysfunction of this system can contribute to compulsive disorders, such as eating disorders, okay? There's another catch, is that these same systems in the brain are interacted upon by drugs of abuse. And in an extreme circumstance, they can essentially become hijacked, so that things that used to give you pleasure, like going out for dinner, or like taking your kids to the park, or like whatever it is, no longer really give you any pleasure, because this system has been changed by this chronic drug use, so that the only real thing that gives you pleasure is the drug use. But as you'll see in a moment or two, that drug use isn't only propagated through pleasure, it's also propagated very strongly through negative circumstances. And so, in other words, drugs become more important than anything else to the individual. So why do people take drugs then? Because I would argue that people that don't take drugs are unusual. And the statistics show the majority of people use drugs. And that's if you include tobacco and alcohol as drugs, and I do. The majority of people use drugs. There's very few people that have never drank alcohol, never smoked one cigarette, and as you'll see, increasingly so using other things. Now, if you talk to people that use drugs, you find out different people use drugs for different reasons. And so some might simply do it to relax or during recreation. Some may be attempting to self-medicate some other underlying disorder. Some may do it as a consequence of peer pressure. Okay? Some might just want to be different, the opposite to peer pressure, if you like. So you see, not everyone's going to use drugs for the same reason, and not everyone obviously becomes an addict, but even if they do, not everyone necessarily, if you take alcohol as an example, it's a polymodal disease, which that means is that not everyone has the same kind of diagnostic criteria. There may be a common feature that they all drink excessive alcohol, but how they got there could be different. So let's think of, broadly speaking, 3 different classes of abused substances. We have stimulants, such as caffeine, that is the most widely used psychoactive substance in the world. Everyone drinks this in coffee and tea. By the way, if you don't drink coffee and you do drink tea, there's caffeine in tea. Cocaine, amphetamine, Depressants, alcohol's a depressant, opiates are depressants, benzodiazepines are depressants. And then we have hallucinogens such as LSD, magic mushrooms, mescaline, a whole range of compounds along those lines. Heroin is obviously the most famous opiate. It used to be purchasable over the counter as an antitussive, an anti-cough medication. Opiates are very good at stopping you cough, and it used to be available freely without a prescription as an antitussive. No longer. There's some mushrooms, magic mushrooms, and this is not cocaine. This is actually an energy drink like Red Bull, which is available in the States, called cocaine. It's got about, I think the amount of caffeine in a can of cocaine energy drink is about 4 times that of Red Bull. So it's a massive hit of caffeine. So if we think about stimulants, about 6 mugs a day of strong coffee is about the equivalent of a low dose of amphetamine in terms of its capacity to act as a psychostimulant. Cocaine is a very good, very clean psychostimulant. It's also a local anaesthetic. It's got a very short half-life, cocaine has, because of its chemical structure, it's broken down very quickly in the body, so it's a very fast on and it's a very fast off. And that's kind of like the ideal property for a drug of abuse, because you get this very salient effect that's short-lasting and you want to repeat it. Obviously, more recently, amphetamines are in the press every day. You can't go a day without hearing something about ice. It used to be ecstasy and now it's ice. The reality is, though, that only impacts a relatively small number of people. It causes problems for people that use it and use it regularly, but there's a relatively small number of people that use it compared to the people that get problems from using alcohol or problems from using tobacco. As I said before, 98% of all drug-related deaths are caused by alcohol and tobacco. You have to remember that. And then pseudoephedrine, which is found in these decongestants, although they're not so easy to get anymore because chemists get burgled and all of these pseudofeds get stolen and ground up to make methamphetamine. If we think of depressants, we've got alcohol, we've got opiates, we've got benzos and GBH. And the thing with these is at high enough doses, all of them will kill you without fail, acutely. If you take too much, if you overdose acutely in any of these, you can die very easily because they can depress your respiratory centers in your brainstem, and if you stop breathing, you don't have long to go. Okay, so I told you before that my opinion is that drug use is normal, and in fact, not using drugs is abnormal. So here's some statistics from both hemispheres. The ONS, this is the Office of National Statistics, which is a UK-based statistic organisation run by the UK government. And here we have the Australian Institute of Health and Welfare over here. So this is just looking at England and Wales alone. We've got over 350,000 13-year-olds drinking alcohol in England and Wales alone. 350,000 13-year-olds, okay? Okay, we come to Australia. A third of the entire population of Australia aged over 14 has used cannabis at least once in their life. A third of the entire population aged over 14. About 2.5% of our population, around about 400,000 people, regularly use opioids. Now that's not just heroin, intravenous heroin users. That increasingly includes prescription codeine formulation abuse. Okay, it's one of the fastest growing areas of opiate dependence there is around the world is the abuse of prescription painkiller medication. And then if we look at amphetamines, this is all of the amphetamines. About 10% of the Australian population use amphetamines. But if we look into the age bracket of 20 to 29, 1 in 5 people. It's a lot of people. Now, Australia's a small country, 22 million people. But these percentages are very similar in many countries around the world. So you scale that up to somewhere like the USA, which has got 400 million people as a population. Yeah, it's a lot of people. It's a lot of people. One thing you'll see, though, is that it often occurs or initiates during adolescence. And teenage years are typified by experimentation and risky behaviour. It's part of development, it's part of growing up. But early adolescent drug use may and can predispose later adult onset substance abuse and major depressive and other mood disorders. It's quite clear, there's no question of that. And then, so you consider this, and then you consider this. The two things don't really make sense, because now we have over 90% of Australians aged 14 and over report alcohol use, and 40% admit experimentation with illicit drugs. And they're the ones that admit it, okay? It's a lot of people. So if we look in the States, this is some data from 1975 to 2008, looking at 12th grades. So what, 17, 18-year-olds. Back in the 70s, about 40% were smoking, but not so many using cannabis. And then you see the smoking rate has come down, but the two things have kind of branched out or leveled out at around about 20%. So there's not, that's 17 to 18-year-olds in the USA, okay? Now, so that's usage. Now let's look at what happens if you develop a problem with cannabis. So the yellow bars here are the general population, and the red bars are the people that have a marijuana dependence, cannabis dependence, okay? So we're not talking about someone who's smoked cannabis once, we're talking about somebody who smokes cannabis regularly and can't really function without smoking cannabis or eating cannabis. It doesn't have to be smoked. So you see, any mood disorder, the average rate of mood disorders within the general population is around about 20%, okay? If you're dependent on cannabis, it's about 3 times, about 60%, okay? So it's triple the normal rate of mood disorders. And so if you look at anxiety, specifically anxiety is close to triple, depression, again, close to triple, mania, 8-fold. 8-fold increase in mania in marijuana dependence compared to the general population, okay? Now, I don't want to scare people here, but we're talking about dependence. Again, I want to stress, we're not talking about someone who's had a couple of joints. But it's pretty clear cut. It's pretty clear cut. So the question is, were these people just a concentrated group of people that were going to be within here and they're self-medicating, or has that use precipitated other problems? And the reality is probably both are true. There's probably examples of both, and there are examples of both. So if we think about what happens in the brain, you know, if you're going to do this, as I said, you know, you experience a pleasurable experience, you've got to experience pleasure, it's driven through the brain, and you decide that, well, that was nice, I'll do it again. And so there has to be a system in the brain to tell you that was nice, maybe it would be a good idea to do it again. So what's the system in the brain that tells us that? So it's quite complicated. This is only part of it. This is a kind of a cartoon of some of the connections, not all of the connections. But what is very important is there's a group of neurons in the ventral midbrain residing in this place called the ventral tegmental area, or the VTA, that make a chemical called dopamine, okay? And these neurons project to multiple places, but what's really important from a point of view of, oh, that was nice, I should do it again, is this dopamine being released into this structure here called the nucleus accumbens, also down here, which is actually not shown, into the amygdala, and furthermore up into the prefrontal cortex. These neurons up here are very important in driving our decision-making process, and they actually send projections down to here and back down to here using an excitatory transmitter called glutamate. But that we don't want to get too complex in the description. But the point is, there is this circuit in the brain that has evolved for, as I said before, for natural rewards, like eating, like having sex. You know, because, you know, if things like that weren't positively reinforcing and weren't pleasurable, why would you bother going and doing it again? And therefore, you know, a species would become extinct very quickly. The other thing I told you is that there's all these different classes of drugs of abuse. So we have stimulants, we have depressants, we have hallucinogens. So how come they have the very distinct, diverse pharmacological properties of all these compounds, and yet they all are addictive? Well, that's because acutely they all share one common property, and that is the ability to increase the release of dopamine in the nucleus accumbens. So this is a cartoon of a neuron. This is the cell body in the ventral tegmental area making dopamine, and this is the terminal up in the nucleus accumbens. And you can see opiates, for example, have a distinctive mechanism of action called disinhibition, whereas nicotine is direct stimulation. But the net consequence of the two effects is the same, is that we increase dopamine release in the nucleus accumbens. Psychostimulants like cocaine act here, where they prevent the mechanisms that remove the dopamine once it's been released, so it stays around for longer. Okay. And you can have inhibition of negative feedback, such as by caffeine, sorry. So you see all of these drugs, quite different properties. Some are stimulants, some are depressants, some are hallucinogens. They all have this ability to do this, one way or another. The net effect is the same. You don't have to take my word for it. Here's some empirical evidence in humans, and I'm going to show you some empirical evidence in rodents as well. So this is a functional MRI scan in humans with alcohol taste, and you can see this profound activation here, which is here on a coronal section. It's the nucleus accumbens of a human, profoundly activated following alcohol taste. Okay? Here we see an experiment in a rat where we actually can measure the release of these chemicals essentially in real time within the brain while they're performing complex behavioural tasks. And so this data has been normalised, so you can see here 100% basically means normal baseline levels. The white dots are dopamine and the black dots are serotonin. And you must have all have heard of serotonin because you must have all have heard of SSRIs, which are antidepressants, which are selective serotonin reuptake inhibitors, in theory. In practice, they're not that selective. But anyway, so this experiment, rats were given the opportunity at this point in time to self-administer as much cocaine as they wanted. They weren't forced, they could choose to take cocaine. And you can see the consequence of that cocaine use increasing rapidly, fourfold, the levels of these chemicals in the nucleus accumbens. And then they stay up, they stay very high, and then at this point in time, the animals' access to cocaine is withdrawn, so they no longer have access to cocaine. And you can see there's a bit of a renormalization. This is just the wearing off of the drug in the body, because obviously they've still got some drug on board, and then that just represents the biological half-life of the drug. But the one thing that I'll draw your attention to here is that when it's all over, it's not just going back to where we started from. You see, they go down here very, very low. And this is an acute withdrawal. Every time you use drugs, the use of drugs is a combination of the initial acute euphoric effect of the drug and then acute withdrawal of the drug. So a good example of acute withdrawal of a drug is a hangover after too much alcohol. That's acute withdrawal from alcohol, okay? But you see here, this is characterized by this system where these transmitters that are very important in helping decision making and regulating our mood are depressed. They're very low. I just told you that an SSRI is an antidepressant, and one of the mechanisms of action of alleviating depression, even though they're not great at doing it, is by increasing serotonin levels. So here you've got decreased serotonin levels, so it only goes to show that that would be dysphoric, would be unpleasant, would be, giving you a vulnerability to being depressed or anxious. This is real data from real live animals. So if we think of this from a psychological construct, this is a hedonic scale. So state A is going towards positive, euphoria, and state B would be going down negative to dysphoria, okay? So, we're going along, we're pretty okay, we're just middle of the road. We use some cocaine, for example. We think, wow, that's great. We get this massive euphoric effect of the cocaine. It decays, and then we go into this acute withdrawal. Happens every time we use drugs. It's just that sometimes the acute withdrawal may not be profound enough for you to actually be particularly aware of it. This is your first experience. The problem is, it's I told you it's a trade-off between these two experiences. So while the plus side beats the negative side, you're going to go back and repeat that behaviour because it's a net positive outcome, and you'll think, well, yeah, I can take a little bit of, you know, little bit of an after effect, a mild hangover, whatever it is. I can do that. I'll carry on the next time because this part of it was so much better than that part was bad. And so the good outweighs the bad, so you go back and do it again. Problem is, when you've done it lots and lots of times, the good's not so good, but the bad's really bad, okay? And so we get this transition. It's called the opponent process theory. It's a psychological theory. But I've just showed you some neurobiological evidence for it. That as you become more and more dependent upon a drug, your mood becomes more and more depressed. And so the reason for maintaining drug use can be, not always, but can be, an attempt to get out of this hole that you've put yourself in, okay? So it's no longer driven by wanting to get high, it's driven by not wanting to be low, okay? So we have two types of reinforcement. As I just said, positive reinforcement, where drug taking is associated with happiness and therefore repeated, and negative reinforcement, which is associated with anxiety, with depression, agitation, and drug taking is renewed to prevent the occurrence of negative symptoms. Okay, so I'm going to give you a quote now, and I'm just going to let you all read it. It's from Edgar Allan Poe. You've probably all heard of Edgar Allan Poe, a famous author. Had a particularly bad habit of using psychostimulants, particularly cocaine. So you can just read it for yourselves. So you see, he's not using drugs to get high at all. He's using drugs not to be low. Yeah? Okay. So I told you that drug use was prevalent. Well, drug use is also typically protracted, which means people tend to do it for a long time. And here is a lady smoking a joint at a Seattle Hemp Fest, and she's probably been doing it for quite a number of years. A serious side to it, though, that the estimates are conservative estimates that by the end of this decade, those aged more than 50 years old that are actively seeking medical assistance for substance abuse problems will be, this has been revised to somewhere between 4.5 and 5 million people. Now that might not sound a lot of people to you, but the thing you have to remember is that substance abuse is not like high blood pressure. So if you've got high blood pressure, I would imagine that 99% of people with high blood pressure would want to get some prescription medication to, or have some kind of remedial action at least to renormalise their blood pressure, i.e. they would actively seek medical assistance to deal with a medical problem. With substance abuse, the minority of people actively seek medical assistance with their problem, even though they know they've got a problem. And that's for many reasons. It's for issues such as, so the minority of people seek assistance for substance abuse problems because of legal issues. You know, their substance abuse might be against the law. For stigma issues, for cultural issues. You know, some cultures, for example, women aren't allowed to drink alcohol. So if you're a woman drinking alcohol in a certain culture and you've got an alcohol problem, you're not going to tell anyone. You know, so it's really problematic, very problematic. And it's very expensive. You know, it costs Australia $56 billion a year. Substance abuse, that's the cost to the Australian economy 5 years ago, it was $56 billion. And as I said before, small population, 22 million, multiply that up over somewhere like the USA. So the estimates are that in developed Western countries, drug and alcohol abuse costs an economy around about 3 to 3.5% of GDP a year. Okay, that's a lot. In China, there are over 1 million registered heroin addicts. That's just the registered ones, 1 million. registered, and they're the minority. Okay, here's another quote. This is an addict, and his definition of addiction was when you can stop, you don't want to, and when you want to stop, you can't. Pretty good definition, really. So, we know that not all people that use drugs become addicted, but we do know that chronic drug use, particularly stimulant use, reduces dopamine signaling in the brain, that molecule I told you about before. So along the top, we've got humans, we've got monkeys, we've got rats. And humans using cocaine, you can see the reduction going from red to yellow, yellow to less yellow in the monkey, and the same in the rat. So it's pretty conserved. It's a very conserved effect. It's not just something that's unique to humans. It will have the same consequences in animals, okay? You can train monkeys to self-administer cocaine, and if you don't intervene, they will self-administer until they die. And the other thing that we see with chronic long-term use of drugs and alcohol, and this is alcohol, is that if you think about it operationally, addiction is kind of like the transition from a motivated behaviour into a habit, okay? It becomes a habit, it becomes habitual, it becomes has a degree of automaticity associated with it, and it becomes relatively insensitive to punishment and things like that. And what we see, you saw here again in social drinkers, this activation of the ventral striatum or the nucleus accumbens with an alcohol cue, whereas in heavy drinkers, that shifts from the ventral striatum to the dorsal striatum. Okay, that activation. So you see this ventral striatum is no longer as activated as it was here, but we see this profound activation in the dorsal striatum. And that degree of activity links in very well with obsessive compulsive drinking scores, okay? Fixation about alcohol, craving for alcohol, okay? And this is the part of the brain that drives your habit-forming behaviour, okay? And so the reality is it's slightly more complicated than that because we've got two streams. There's a stream of neurons. These are two different pictures that mean the same thing. It's a circuit in the brain, and through this dorsomedial striatum, we have a motivated stream of behaviours, and when that shifts laterally, you kind of shift from a motivated behaviour into a habit. Now, some habits are good. Brushing your teeth's a habit, it's a good habit. But, habitually using something that might kill you is not necessarily such a good thing. So the reason we have these circuits that are for habits is because we do need habits in our life. But when you start shifting away from a motivated behaviour that is sensitive to devaluation, it's sensitive to punishment, it's sensitive to adverse consequences, you move across laterally, the behaviour is no longer sensitive to devaluation, it's no longer sensitive to punishment, it becomes much more automated, and that's when you've got a real problem. So if we think about that, here's another definition of addiction from a musician, and it's when you can give up something any time as long as any time's next Tuesday. So it's just like tomorrow never comes. You say, I can stop that tomorrow. So, but there's no such thing as tomorrow because tomorrow's always the next day. So there's lots and lots of definitions of addiction, but I like this one, and it's that it's a chronic relapsing disorder which consists of a compulsive pattern of drug-seeking and drug-taking behaviour. And in humans, there are a number of features of it, but these are cardinal features, and that is that this behaviour takes place at the expense of other activities, and that it persists despite adverse consequences. Okay. Now, the adverse consequences are complex and multiple. And so, for example, let's just think, okay, so you're a smoker and you get lung cancer and you die from lung cancer. That's an adverse consequence to you because you're no longer alive because you've died of smoking-related disease. But let's just say one of you guys step out of here tonight, you cross the road, you go to the tram stop on Royal Parade and you get wiped out by a driver and killed, and that driver blows point 1, point 2. It's not an adverse consequence to the person with the alcohol problem, it's an adverse consequence to you because you are dead. You're collateral damage of someone else's substance abuse. So you see, And that's the one thing that a lot of people don't consider. And in fact, the degree of harm caused by alcohol, either to the individual, to their family, or to society more generally, is far higher than the harm caused by, say, heroin addiction, for example. Far higher. You know, around about 20-25% of all road deaths in Victoria are alcohol-related. You know, huge. The figures are unbelievable. And around about 10% of the global burden of disease comes from substance abuse. So remember these two things. They take place at the expense of other activities, and they persist despite adverse consequences. Okay. And it's a compulsive behaviour. So here we have an experiment in rats to try and see if we can stop this kind of compulsive behaviour. And so these red dots are where a virus has been injected into the brain to deliver either a microRNA or to prevent the expression of a microRNA. And microRNAs are small bits of genetic information that we believe in this instance are actually part of the body's endogenous protective mechanism that means that many people can use drugs without becoming addicted, okay? And that failure of this mechanism makes you more vulnerable to becoming addicted. It's not going to be the only reason, but we think it may be one reason. And so here's the evidence. If you look down here, these are control animals self-administering heavy, large amounts of cocaine, over 100 infusions in a session, lots and lots and lots of cocaine. If we actually overexpress this microRNA in this part of the brain, which is, I just told you before, this is the rat striatum, this is the part of the brain that's driving that habitual behaviour. If we overexpress that microRNA, the cocaine use gradually goes down. And this is possibly even better experiment. Here's the guys doing the normal control animals. And this treatment's the opposite treatment where we've prevented the expression of that microRNA, of the endogenous microRNA, by blocking it, and their use escalates. So if we dose them up with this particular microRNA, they reduce their cocaine use. And if we block the microRNA, they escalate their cocaine use, okay? So what are components of the addicted human state? Clinically, relapse is the real problem because you could take anybody who's addicted to any drug and detoxify them and manage them through a managed stage withdrawal process and render them no longer dependent upon a drug, whatever drug it is. But the problem is keeping them that way, and that's the hard bit. Relapse is a real problem, and it's an enduring problem as well. And it's simply an inability to cease drug taking. And we think this is underscored by persistent adaptations in this motivational circuitry in the brain, and this phenomenon of incubation of craving or drug wanting during abstinence. And I would make a distinction between wanting and liking. You don't need to like something to want it, okay? They're quite separate. And what we mean by incubation of craving, it may be counterintuitive to some of you, but it's been demonstrated empirically in animals and it's been demonstrated in humans as well. And what that means is, if you think about the word incubation, it's kind of a hint. It tells you that the longer you've been clean, in fact, the more likely you are to relapse, not the other way around, within a certain time frame, okay? And it's empirically demonstrated, as I said, in rats, in primates, and in humans. Okay, it's quite clear. Okay, so if we think about craving, if craving is something that drives relapse, think of these definitions. They all, to me, demonstrate some degree of desperation, to long for, to want greatly, to desire eagerly, to require, to need, to beg or plead for, an urge to consume. That all implies some kind of desperation. Okay? This is a heroin addict. No, doc, craving is when you want it. You want it so bad you can almost taste it. But you ain't sick. Sick is well sick. So you see, this person could identify the difference between craving and knowing they're going to relapse versus being unwell. Okay? And you may think that relapse, and some people will tell you this, that it's a completely out of control, complete loss of control behaviour. Well, it's not at all. It's perfectly controlled. If you think about what you have to do to relapse, you have to decide you're going to relapse. There's a conscious decision. So something you've experienced, something, you've had a bad day, you've lost your partner, you've been sacked, you've been arrested, or you've seen cues or friends that were associated with prior drug use, or a combination of all of those things, and you start getting a bit twitchy and you think, oh, gee, I'd love a drink, or I'd love a line of Coke, or whatever it is. So the first thing you've got to do is make a decision that you're going to go and use the drug. So what do you have to do once you've made that decision? You've got to get some money. So what do? You go to the ATM, you draw out some money. Or what if you don't have a bank account? What if you don't have an ATM card? What if you've got no money in the bank? You've got to get some money from somewhere else. You know, what are the choices? You steal something so you can sell it to get some money. You sell your body on a street corner. You've got to get some money somehow, okay? But this is the reality, is what happens. So you've decided you're going to relapse, you've managed to get some money from somewhere, and then what do? Well, you've got to go and buy your drug. So if it's alcohol, it's easy to go down the bottle shop. But what if it's heroin? You've got to go somewhere where you know you can get it. So you've got to relocate yourself again from the source of money to the source of procuring the drug. And then you've got to get it. And then you've got to think, well, I'm going to use this drug somewhere where I feel comfortable to use the drug. So you've got to get yourself from wherever you purchased the drug to an environment where you feel safe and secure to use the drug. And then finally, you actually use the drug. So that's really just the climax of a whole series of very complex, highly orchestrated decision-making processes. So you see, if you were totally out of control, you wouldn't be able to pull it off if you wanted to. You see? Okay, so if relapse is a problem, how can we work out to try and do something about it? So these are, again, is fMRI, functional magnetic resonance imaging in the brain of alcoholics. And what they did, this was a German study about 10 years ago, just over 10 years ago now. And what they did is they put the people in the magnet, they showed them alcohol-related cues and neutral cues, and they made them fill out self-rated craving scores. And then what they did as well is they followed these people afterwards to see when they'd relapse and how much alcohol they'd consume. And what they found was activation of the striatum, this habit area, but that had no bearing on their relapse. It wasn't related to their craving scores either, and neither did their craving scores have any bearing on when they would relapse or how much alcohol they would consume. Here we see this very strong activation in the medial prefrontal cortex, which is where your inhibitory control is kind of resident, if you like. And these neurons project down onto these neurons and provide that level of control and drive the outflow from here. The alcohol cue-induced activation of this part of the prefrontal cortex was very, very highly related to the propensity to relapse and the amount of consumption upon relapse. Okay. Suggesting that what we're having in the addicted brain, if you like, in the case of an alcoholic, the alcoholic brain, is that the alcohol-related cues take upon an exaggerated salience, okay? So they're far more meaningful than the negative cues or the neutral cues, and they have a far greater impact upon decision-making as a consequence of that salience. So a whole range of studies, in imaging studies in humans and more interventional studies in animals have worked out, to a large extent, a bulk of the circuitry that drives drug-seeking behaviour. But I would say this is still only a snapshot of it because we've still uncovered new components that aren't integrated on this. But we have, as I mentioned to you before, relapse can be triggered by a cue, it can be triggered by a stressful event, both separately or together. And if it's a cue, we know that a specialised part of your amygdala called the basolateral amygdala is critically involved, is critically required for integrating the salience of the cue, feeding that in with the prefrontal cortex, and then out through here, through this outflow structure. If it's a stress, then there are other parts of the amygdala that have nothing to do with cue salience, but are very, very implicated in stress reactivity that drive that. And we have some structures that are involved in both of them. Now, this red so-called final common pathway is called that because if we intervene and disrupt the information flow through any of these three nodes, we can prevent relapse. Okay? So we know the circuit that drives it. Okay? We also know that the neurons that start here and project down into the accumbens they're excitatory. They use a transmitter called glutamate, which is the major excitatory transmitter in the brain. And so there have been some experiments around looking at the regulation of this glutamate system in these neurons. So if you like, this is a normal brain, and this is the terminal of one of these glutamate neurons that's projecting from the cortex down into the nucleus accumbens. And this is the cell in the accumbens that it's making a connection with. You can see here in this this blue circle, the major mechanism for removal of glutamate from the synapse once it's been released is this transporter protein that's found on a glial cell that is adjacent to the neuron. Okay, it's called GLT1. And because we don't want the glutamate to be in the synapse for longer than necessary. We want it to be released quickly, activate these postsynaptic receptors, and propagate the signal beyond. And then we want it to be gone. And if it stays around for too long, it can be toxic and it can do all sorts of things. So what happens if you're addicted to cocaine? If you're addicted to, this has been proven in animals for cocaine, for heroin, and for nicotine, 3 completely different drugs. They all show this same thing, in that there's a downregulation of the expression of this transporter, which means, and there's also a reduction in the function of this transporter, which means there's more glutamate floating around, higher levels for longer, and it escapes from the synapse and activates and causes synaptic adaptation on these what we call extrasynaptic receptors. And that's a bit complicated, but the bottom line is we go from a normal brain to an addicted brain, and the glutamate homeostasis is dysfunctional. It's impaired. The ability to regulate glutamate within this key synapse has gone. Okay? Now, the other thing that we know is that there's this compound, N-acetylcysteine. Now, you can go in a health food shop and buy this. It's freely available. We know that this, we don't know how it does it, but we know that it does it. So one of the keys is to work out how it does it. But we know that if you take animals that are addicted to cocaine, that are addicted to nicotine, that are addicted to heroin, that have this dysfunctional glutamate system here, and we treat them with an acetylcysteine, we can renormalize that glutamate system. We can put it back to where it used to be, okay? And that is associated with far less propensity to relapse in the animals compared to the untreated animals. So, you know, the clever ones in the audience here are going to be sitting there thinking, well, geez, if it's that straightforward, how come this doesn't just solve addiction? Okay? Well, let's see. So, 8 years ago, there was a trial in cocaine addicts, in humans, for this compound. Just a small proof of concept trial. This is a quote from the paper. You can look it up yourself. This is just taken straight out of the paper. For the 16 subjects who completed the study, 9 terminated use of cocaine completely during medication phase. 5 substantially reduced, and 2 just carried on going using cocaine. Okay? So it did something. Not for everybody, but for some people. You know, if we go back to blood pressure and hypertension and drugs, you know, some people are on ACE inhibitors, some people are on calcium channel blockers. So, you know, your doctor might start you off on an ACE inhibitor, it doesn't work. You move on to a calcium channel blocker, it suddenly works. So, you know, different drugs work for different people to bring their blood pressure down, just as different drugs may help different addicts reduce their drug use. Okay? There are currently ongoing clinical trials with this for numerous different drugs. I'm not suggesting it's a silver bullet, a magic bullet whatsoever. But even if it only assists a fraction of the people, it's worthwhile, because at this point in time, there is not one drug, therapeutic drug, licensed for the treatment of cocaine dependence. Not one. Not one. Okay, so if addiction is this loss of control over drug use, but I did say control over drug use, i.e. escalation of drug use, not loss of control in the ability to procure drugs, or compulsive seeking and taking of drugs despite adverse consequences, remember that. Why then do only a subpopulation become addicts? And I've told you about these endogenous protective mechanisms, and we'll come back to a bit more of a sociological level now. So here we have a range of different behavioural domains controlled by the individual, by the family, by a peer group, by a community. Okay, early aggressive behaviour is a big risk factor, whereas self-control, high self-control, is obviously a protective factor. And we can go all through all of these things. But the bottom line is, if you've got good self-control, if you're in a stable, supportive family environment, you're involved in community organisations, you have a sense of association, you have a sense of belonging to something, you get educated at home and at school with anti-drug use policies, they're all going to protect you. Whereas if you experience all the opposite, then it's not going to protect you. So let's have a look at this transition from episodic drug use to addiction. So we start over here. This is some use-prone character. Starts out using cocaine on a Saturday night. It's great. They love it. I think, okay, but I'm okay. I can wait till next Saturday. Here you see this pie chart is the way they engage themselves on a day-to-day basis. You see they still go to work, that's the productive activities in red. They still like to go out for dinner, that's the consummatory activities here. They still like to have other forms of recreation, not just drug use, have a small amount of drug use, and they still enjoy having sex with their partner or whoever. Okay, so they've got pretty much a broadly normal, typical existence, apart from this little bit of drug use, okay? And then that kind of moves in these prone people. They may, as I've shown you with some of those experiments, escalate their drug use, become more prone to developing a habit. So what happens? They still go to work, they still hold down a job, they still enjoy having sex, they still enjoy going to the restaurant, but they spend more time thinking about getting drugs and using drugs and less time in other recreational activities. Okay, that's the first thing that will happen. And then you move over to this kind of full-blown, I don't like the word loss of control, but this isn't my publication. When they say this, they mean loss of, an inability to regulate drug use as opposed to, you know, there's different nuances on the meaning of control. But you see, what you see here is all of a sudden they no longer got a job, or they're finding it hard to hold down a job. They're no longer kind of engaging with their partner. They are doing very little other than spending most of their time not only just procuring drugs and using drugs, but actually thinking about drugs. So they spend their time planning. Oh, you know, looking at the clock, geez, I've got another hour to go before I can go and get smashed. You know, it's that preoccupation of using drugs. It takes up a lot of their time. Nevertheless, addiction is this kind of triumvirate between your genetic makeup, the neurobiological effects of the drug in your body, and your environmental experiences, as I've just shown. But from a genetic perspective, there's no answers, I'm afraid. There's no such thing as a definitive marker gene that's going to say you're going to be an addict or you're not going to be an addict. It just doesn't exist. One of the problems is there's an enormous psychiatric comorbidity with substance abuse, and there are other problematic things as well. So there are some marker genes that give you an odds ratio, but they're not always necessarily replicated within different ethnicities or between different ethnicities, should I say. There is one exception. There's a very good example of a protective mutation in the Han Chinese population, which renders them unable or unable to metabolize alcohol well. So they have when you drink alcohol, it's metabolized in your liver by a series of enzymes. The first one is called alcohol dehydrogenase, and what that does is it converts the alcohol into something called acetaldehyde. Acetaldehyde is very toxic. It's very toxic. And if you can't, and then so there's a second enzyme called aldehyde dehydrogenase which breaks that down. If you can't break down acetaldehyde, you will go bright red very quickly. So if you see someone has one or two drinks, their face goes bright red, they start sweating, they feel dizzy, they feel nauseous, That is because they've had this rapid buildup of acetaldehyde in their body because they've either got a polymorphism that means they're a poor metabolizer, or their liver's stuffed and they can't metabolize anyway. Okay? And that is the basis of one of the treatments to stop people drinking alcohol, by making it aversive. Now, in theory, that should work very well. And for people that use it and are compliant with it, it does work very well. But the reality is, if you're taking a drug like that and you want to drink alcohol, you just stop taking the drug. So compliance is a real problem. So you think, I want to have some alcohol, so I'll just stop taking my medication, wait a few days, I'll be right, and start drinking again. And that's the problem with humans, not just for addiction, but for any disease. You know, you go to the doc gives you a script, you go to the chemist, you get it. You know, you'd be surprised how many people actually don't take the medication that they're supposed to take, the dose they're supposed to take, when they're supposed to take it. You know, lots of people. Good example, particularly with psychiatric disorders, you know, they might feel unwell, take the medication, suddenly, I'm okay now, I can stop taking the medication, rather than realising the reason they feel okay is because they're on the medication. And so it's very problematic. And so you can look anywhere, you can read anywhere, there are all these candidate genes, but I can tell you not one of them is going to say, yes, you're going to be an addict. They might give you an odds ratio. They might say, okay, you have a genetic mutation that might make you more prone, but at the end of the day, you've still got to use the drug. Because you can have whatever genetic propensity or vulnerability you want, but without using the drug, you're not going to become addicted. But as we've saw before from the statistics, most people actually do use drugs. And so therefore, it becomes really Russian roulette, because you don't know whether or not you're going to be vulnerable necessarily, unless you've got a long family history, for example. You don't necessarily know what your vulnerability is. And so it is like playing Russian roulette. You might find out, it might be too late when you find out that you're already, you know, down a nasty path before you realise that, well, maybe that wasn't such a good idea after all. But you see, the thing is, as we saw, a lot of drug use starts in teenage years, and every teenager's bulletproof, you know. All of us in the room here, you were all bulletproof when you were teenagers. Everyone is. It's not unusual. Here's an example of a mutation, though, that is a mutation in an opioid receptor in the brain. That this is the body's own endogenous painkillers. These are the receptors that opiates act on, like heroin, like morphine. But they're also, opioids are also implicated in the reward that you get from alcohol. Opioid receptor antagonists are used to treat alcoholism. And that's because when you drink alcohol, there's a neuron, these commence in a part of the brain called the arcuate nucleus of the hypothalamus. They release an endogenous opioid peptide called beta endorphin. And that activates a mu-opioid receptor on this GABA interneuron that's in the VTA that is normally inhibiting the activity of this cell. And what this does, what the opioid does, it disinhibits this cell and releases dopamine, so therefore makes you feel happy. So you see here, the red, these guys with the AG mutation, they get a massive release of dopamine into the nucleus accumbens with alcohol, whereas these people don't. And the interesting thing is as well that this AG mutation dictates the treatment response to naltrexone. So if you've got a G, you'll have a far better treatment response to naltrexone than if you don't have a G. But you can see the variability. In Africa, less than 1 in 10 people are a G carrier. In Asia, it's about 50%. And the Caucasians, about 30%. So you see, this is an example of a mutation that not only dictates your kind of subjective response, euphoric type response to a drug experience based on a neurobiological mechanism, but it also dictates whether or not you're going to get a good treatment outcome to a therapeutic. Okay, so coming kind of last few slides now. Addiction is essentially a combination of a physical dependence, and I've told you that that's relatively easy to overcome, and a psychological dependence, and that's very hard to overcome, very hard indeed. And this kind of requires lifestyle change, and it's really this and the neurobiological mechanisms underpinning this that essentially drive relapse. So what is withdrawal? You know, acute withdrawal is clearly a characteristic sequence of events. It's related to the drug taken, but there are some generalizations such as anxiety, such as lack of sleep, nausea. Typically, you end up in this what's called this post-dependent dysphoric state, and as I told you before, that post-dependent dysphoric state can be a very strong stimulus to recommence drug use. So the question is, well, can brain function recover after abstinence? Well, sometimes. So if we see here, this is a prolonged abstinence of methamphetamine. So here you see a healthy control, and here you see a methamphetamine addict. Down here again, the healthy control. This is 1 month abstinence of methamphetamine. This is just over a year abstinence of methamphetamine. So it's looking much better. So it's not necessarily unrecoverable. However, some things are unrecoverable. So here we see an MRI, a structural MRI of a normal healthy person. You see these ventricles? These are holes in your brain which are the kind of roadways where your cerebrospinal fluid flows through, providing nutrients to your entire brain. And here we can see this massive expansion of the ventricles in this alcoholic. That's not recoverable, okay? So recovery really depends on the degree of damage that's been caused to start with, okay? And here we see in animals some empirical evidence that withdrawal does cause depression. So this is what we call a forced swim test, and what we do is it's a measure of despair in the animals, and the amount of time they spend immobile or not attempting to escape is an index of how depressed they are, if you like. Here we see the control animals. You know, this is 2 weeks after withdrawal from chronic alcohol intake. We can see they are very depressed. They're not happy campers at all. And that is associated with a reduction in neurogenesis in the hippocampus. And the hippocampus is very important for learning and memory and cognition, hence going back to my very first slide where you all thought I couldn't spell. So not only does withdrawal make you depressed, anxious, dysphoric, it reduces the capacity of your brain to create new neurons. And those new neurons are being born in all of our brains all the time. All of us here now, that we still have new neurons being born in our brain. You know, you don't just have the neurons you were born with, you've got new neurons being made all the time. It slows down as you get older, but it's continuing. Okay, so this can be reversed, both the behavioural deficit and the birth of new neurons, or that reduction in birth of new neurons, both of those can be reversed with an antidepressant treatment. Okay? But I would say antidepressants aren't actually very good at reducing alcohol use. They will maybe help you with your depression, but they're not going to be very good at a population level for regulating aberrant alcohol intake. The other thing that can reverse this in animals is exercise. So you see, here's a control brain, lots of new neurons. This is the effect of exercise in a control animal. You see, exercise enhances neurogenesis in a normal, healthy brain. Here you see this profound reduction in neurogenesis. There's very few little black dots here. This is the chronic alcohol brain. When, during withdrawal, we give them access to running wheels to run, the depression is ameliorated to a large extent, and their capacity to generate new neurons is recovered as well. Okay? So those of you that don't like chemicals and prefer natural remedies, exercise is about as good as an antidepressant, or maybe even better in this experiment. And this is a mouse, by the way. Okay, so why can't addicts just quit? Okay? And that's because addiction changes brain circuits, which gets back to what I said to you right at the beginning. It's a brain disorder because once you're an addict, you have a disordered brain. It's not working the way it was before you were an addict. And this is, if you like, those neurons in the prefrontal cortex providing this top-down control, and these things that are feeding into it, such as your saliency, your memories, motivation, all of which tell you to whether go or no go, stop, go, green light, red light. Well, the bottom line is that when you're an addict, this top-down control, this decision-making process from these neurons in the cortex that I showed you is impaired, dramatically impaired. The cues that are associated with drug use take upon a far greater saliency, and the memory of those drugs is far more important than anything else. And these things, in combination with reduced inhibitory control, put the green light on, okay? So, just to summarise, addiction is a brain disorder. There are gene-environment interactions associated with the development of addiction. The molecular mechanisms that underpin the transition to addiction are beginning to be elucidated, but we still have more to unravel. And, well, this is an open question because the therapeutics that are available at the moment are far from brilliant, and that's our job, is to try and improve on that. And the only way we can improve on that is by unravelling what's going on in the brain in the first place, which will give us a far more targeted approach to treating it. So I'd just like to finish with, for those of you that have teenagers or are teenagers, there's actually a really good website run by NIDA, which is the National Institute of Drug Abuse in the States. This teens.drugabuse.gov, which goes through for young people what taking drugs does to you. And there's NIDA have a thing called the Cool Spot, NIAAA have a thing called the coolspot.gov. This is all about alcohol, and this is a very good site because it gives a lot of insight into peer pressure for young people, how to overcome and be resilient to peer pressure, and it tells young people what using drugs and alcohol is really doing to them. Okay. Anyway, that's it. Thank you.